Okay, so let us proceed to the first law of thermodynamics. No, as I have said kanina, okay, the first law of thermodynamics is about the conversion of energy of a cycle. Okay, so as you can see here, yung equation natin kanina sa taas, no, um, yung equation natin kanina sa taas, that is yung change of internal energy plus change of kinetic energy plus change of potential energy is equals to 1q2 minus 1w2. Okay, uh, naging naging kuha na lang siya ngayon dito sa equation number 3.10, no, naging 0 na lang yun siya, equals to uh, close integral of gradients of Q minus close integral of gradient of W. So, bakit, no? So, as you can see here, no, kung babasahin natin to siya, the first law of thermodynamics talks about when the when the system undergoes a rotation or cycle, that is it changes from a first state to the it changes from the fine of initial state to a final state, and then goes back to the initial state. Okay, so the conversion of energy is, or the energy equation will become 0 is equals to change of integral of change of q minus integral of change of work. Bakit? Kasi as I have said kanina, yung internal energy, change of internal energy natin, at saka yung change of kinetic energy natin, at saka yung change of potential energy natin are all depend on the final state and initial state. Okay? So if we assume here sa first law of thermodynamics that the system goes from the initial state to final state and then goes back to the initial state, okay? If we assume that cycle, ibig sabihin nun, yung kinetic energy natin at saka yung internal energy natin at saka yung potential energy natin are all equal to zero, no? From our from our theorem of dependency of path, no? Independency of path of the system. Okay? So yun. So kung iisipin natin kasi yun siya, no? If the system goes from the final state, from the initial state, and then it goes back to the initial state, okay? So ang nangyari doon is nag-rotate siya, no? Yung cycle, yung transformation niya or yung process niya is nag-rotate or nag-cycle. So ibig sabihin, its energy is bumalik din sa kung ano man yung initial na energy niya, no? Since we have said that energy, no, yung potential energy at saka yung kinetic energy at saka yung internal energy are all depende lang sa kung ano yung state ng isang system. Okay? So, yun ibig sabihin nun. Kaya, ang equation natin is from balance equation, balance energy equation, naging 0 is equals to integral of change of Q minus integral of change of W. Okay? From this equation 3.10. Okay? So, we can just say that integral of change of Q minus is equals to integral of change of W, or no, we can also say that a cycle is a rate, no, as rate of change of Q is equals to rate of change of work, no. So yan yung equation natin for first law of thermodynamics. Okay, so we have here a definition of work, so just read na lang to siya kasi ito lang siya is the um basic definition of work. Now, so just giving you a small or brief discussion about this definition of this work, no? As I have said kanina, ang pinakatatandaan lang ninyo dito is that yung when you say work, no? When you say work, it is depende siya sa path ng system, or path where the system undergoes, in which when it change from one state to another, no, yung path nakadepende siya sa path, and at the same time nakadepende siya sa state, no, ng isang ng changing of a system. Okay, so yun lang yung tatandaan nyo dito. Okay, so it may be equals to, once again, no, when you say work, it may be equal to it may be equals to potential energy again, and it may also be equals to kinetic energy again, no? Kasi meron tayong, at saka yung rotational or yung tinatawag nating ah, yung tinatawag nating rotational kinetic energy, no? So, yun. So, pwede rin yung ganon. Pero, no, pakatatandaan lang natin dito is that as when we say work, yun talaga yung work na nangyari sa system or nagawa ng system. Okay? So, yun. And then, once again, nakadepende siya sa path at saka kung ano yung state ng isang uh, system. Okay? So, yun. So, we have here a different formula, no? As we can see here, um, work is related with um, um, kinetic energy or potential energy, and then the basic formula or the basic definition of work is force multiplied the distance, no, where the object is being moved. Yun lang yung pinakatatandaan yun na formula for work. Okay, so yun. This formula, work is equals to force times distance, is valid only for uh, those system where it undergoes movement, no, as at a certain distance. Okay, so yun. Okay, so we have here a unit of work, no. We know that the unit of work is newton meter or joule, or we can also say that we can also say that um watt per seconds. I mean, um watt seconds, no, watt seconds, yun. Kasi we have here power is equals to watt per seconds, or no, power is joules per seconds. Okay, so if, and then we know that work is equals to power times time, so therefore the unit of work is watt seconds, or in simply joules na lang, or in newton meter. So we have here a conversion from HP, another unit of power, okay, is horsepower, no. So we have here a conversion of horsepower uh from horsepower to foot pounds force per seconds, no. So magagamit din natin siya. Okay, so let us proceed to our example number 2. So basahin niyo lang to siya. Okay, so example number 2 says that um, a car of mass 100 a car of mass 1100 kilogram drives with a velocity such that it has a kinetic energy of 400 kilojoule, no. Find the velocity if the car is raised with a crane. Okay? And how high should it be lifted in standard gravitational field to have a potential energy that equals the kinetic energy? Okay, so it's just a simple calculation. Okay, solution we have here, we have to start with kinetic energy. Now we know that kinetic energy is 1/2 mv squared, no, from your physics. Okay, so this is equals to 400 kilojoule. Okay, so from this we can solve for the velocity. Okay, we have here velocity is equals to square root of 2 ka over mass, no. Just manipulate this equation here, itong equation na to, and then you will derive this equation na v is equals to square root of 2 kinetic energy over mass. So just substitute the value so we can find the velocity, okay, which is equals to 27 meter per seconds. So we have the standard potential energy, therefore is equals to potential energy. No, we know that the formula for potential energy is mgh for lifting an object, no. So iba naman yung formula for spring, and iba rin yung formula for pendulum. Okay, so just lifting of an object, its formula is mass times gravitational acceleration and height. Okay, so since sa problem natin sabi doon, uh, kinetic energy is equals to potential energy, so therefore we can say that potential energy is also equal to kinetic energy. Okay, so finding the value of height, no, manipulate this equation here, itong equation na to, so we can find the height of an object, no, uh, of the car that is being lifted, in which equals to 37.1 meter. Okay. So, example number 3 is the same with example number 2, no? It's just that in here we are dealing with a British thermal, I mean, we are dealing with the English system of units, no? Instead of meter, or yung kinasanayan natin na metric system, we are using here a English system of units. Okay? So, parehas lang yun siya. So, yun. Pinagkaiba nga lang is unit lang. Okay? So, just study that one. Okay, so we have here example number, okay, so supposedly example number 4 to siya, no? Okay, so we have here example number 4. We have consider a stone having a mass of 10 kilogram and bucket containing a 100 kilogram of liquid water. Initially, the stone is 10.2 meter above the water and the stone and the water are at the same temperature. Yes, no, at state 1. Take note of that. So the stone then falls into the water. Determine the change of internal energy, change of kinetic energy, and change of potential energy and heat. Okay, that is being transferred. The work for the following changes of state, assuming that the standard gravitational acceleration is 9.80665 meter per second squared. Okay. So we have here letter A, the stone is about to enter the water. So we assume that that is the state 2. So we have here the solution, no? All of this we can use yung tinatawag nating yung na-discuss natin kanina na energy balance, no? Of equation we have here, change of internal energy is equals to change of kinetic energy plus change of potential energy is equals to Q minus W. Okay? So, sabi dito sa letter A, we have the stone has fallen from Z1 to Z2 and we assume no heat transfer as it falls. The water has not changed state. Okay? So, sa letter A, as the stone goes from the height where it is placed above the water and to to the water, or I mean to the place where it is close enough to the water, okay, there will no be a change of state involved, no, kasi hindi pa man yun siya pumasok sa water, no. So therefore we can say that change of U or change of of energy is equals to zero. Okay, and even the heat transfer is zero din kasi wala namang nag-transfer na heat doon kasi hindi pa sila nag intercontact, and then work is also wala rin, no. So, therefore, the final energy balance equation would be equals to, or would become, a change of kinetic energy plus change of potential energy would be equals to zero. So therefore, change of kinetic energy is equals to negative of change of potential energy, and it is equals to negative mj z2 minus z1, no? That is the formula for potential energy. So substitute the value, so that is equals to 1000 joules or 1 kilojoules for the kinetic energy as it goes from state 1 to state 2. Okay? So letter B, the stone has just come to rest in a bucket, no? Uh, the stone has just come to rest in a bucket. So, ibig sabihin, pumasok na yun siya sa water, no? Nag-intercontact na sila ng water. Kasi nag-rest na siya doon sa loob ng bucket, no? So, the solution here for letter B is, um, for the process from state 2 to state 3 with zero kinetic energy, we have change of potential energy is equals to zero. Bakit? Okay? Kasi, no, there will no be a gravitational acceleration, or even there will no be a difference of height, no, with one reference only, no. So, ibig sabihin, we can say that change of potential energy is equals to zero. Okay? Kasi, syempre, no, nag-rest man yun siya doon sa sa loob ng bucket mismo. So, ibig sabihin, wala siyang potential energy. Okay? And then, since no sa problem, sinabi natin doon that they have the same temperature, the stone and the water have the same temperature, we can say that uh, transfer of heat will also equals to zero, no, since they don't have uh, temperature difference. Okay? And then yung work natin is also equals to zero since there will no be involving work doon sa water natin, okay? At saka doon sa stone natin, okay? Then we can say that change of internal energy plus change of kinetic energy is equals to zero, okay? So since we have already the value of change of kinetic energy from letter A, so we can find the change of internal energy from state 2 to state 3, which is equals to negative 1 kilojoule. I mean negative of change of kinetic energy or 1 kilojoule. Okay? So yun. So letter C is in the final state. The question for letter C is heat has been transferred to the surroundings in such an amount that the stone and water are at the same temperature T1. Okay? So yun. Ibig sabihin there is an involved transfer of heat. Okay? So in the final state, there is no kinetic and potential energy. Siyempre, wala kayong movement, no? Wala tayong movement kasi at rest. So, and the final and the internal energy is at the same as state 1. So, we can say that change of internal energy is negative 1 kilojoule. So, paki-change na lang to siguro dito kasi nagkamali siguro. Ito, dapat negative 1 kilojoule din siya. Okay, so, change of kinetic energy is equals to 0, no? Kasi wala, as I have said, walang movement. Change of potential energy is walang 0 din. And then, the change of work from state 3 to state 4 is also 0, no? And then, therefore, the state of, or the change of heat or transfer of heat from state 3 to state 4, therefore, would be equals to negative 1 kilojoule din. Okay, so ito yung sinasabi ko sa inyo kanina na um, um, energy is being transferred. No? As you can see here from letter A, nagsimula tayo sa 1 kilojoule and then after that, nag-transfer until nag-transfer siya sa isang form of energy na change of heat. No? So as you can see here, naging negative 1 kilojoule. Okay? So yan yung sinasabi ko sa inyo kanina. Once again, energy cannot be created nor be destroyed. Okay? So yun.